Right, let's get stuck into some quantum physics, which sounds very clever, and is very clever, in fact, and will help you pick up hotties at parties, because they're attracted to your outstanding intelligence. Just like my wife was. She's not a dwarf or anything. Now, if we're going to talk about quantum physics, which is fantastic and new and zappy for you, why have I drawn your very old and manky model of an atom that you learned when you were 12 or 13? Well, because we need to understand this in order to understand the front end of quantum physics, and also to understand what we're going to gradually destroy as we learn more detail about it, more higher level stuff. So let's check that we're all singing from the same hymn sheet, that we all understand what's going on here. First of all, you should have thought that I'm drawing electrons orbiting a nucleus. Okay, that's your standard sort of model of the atom. And you've probably been taught that you've got 2 electrons in the inner orbit or in a shell, and then it goes 8 for the next one if you can fill it up. This one isn't full, but it'd go 8, and then you'd have 8, and blah blah blah. It's all a load of rubbish, but never mind, eh? We'll discuss maybe a better version a bit later. Now, first of all, let's look at what's going on. These are electrons, and I hope you know that electrons have a negative charge. Now, in the nucleus, we've got protons. And again, I hope you know they've got a positive charge, and we've got neutrons. And the clue to what neutrons have got is obviously in their name. They're neutral. Now, were we to draw the actual symbol for this atom, and what I've drawn here is a carbon atom, we'd do C for carbon, and if it's your common or garden carbon atom, you'd probably see that. Well, you would see that. Now, what do these things here and here represent? This is obviously carbon. What are these? You've probably learnt that, well, I hope you've learnt that this number up here, you probably called it the atomic mass. Yep, or maybe the mass number. I'll just do a hash symbol. Americans call it a pound sign for some reason, because I can't be bothered writing out a number. Okay, all the time. So you might have called that atomic mass or the mass number. The crucial point, it's got mass in it, and that's because electrons are tiny, wee little things, and neutrons and protons are whopper. So virtually the whole mass of an atom is in the nucleus, and so that's just going to be the number of protons plus neutrons. We generally ignore the number of electrons. However, obviously, what I'm going to do is scratch that. I don't like that system. I don't like calling it these. I understand why we put mass in there to help you realise it's mass, but what I want to call this is the nucleon number. And there's a reason for that. If you look at these, protons and neutrons, the collective name for stuff that's in the nucleus is nucleon. So a proton is a nucleon, and neutrons are nucleons because they're in the nucleus. It's the collective noun. So if we call this the nucleon number, we are telling ourselves implicitly, or borderline explicitly, that it's the number of protons plus neutrons. So I prefer calling it the nucleon number. I think this is a little bit waffly, to be honest. Now let's come down here. What you've probably called this number is the atomic number. Now this for me is even worse, because what on earth does that mean? You know, this doesn't connect what this number represents with anything really. And also, because it hasn't, it leaves a little gap for your brain to jam some rubbish into. Because if we look at a carbon atom, what you discover for carbon is that it's got 6 electrons, 6 protons, and 6 neutrons. So what your brain thinks is, well, okay, I understand that 12. That's your 6 plus 6 for your neutrons and protons. Where's the number of electrons? Here it is. Your brain just naturally goes, well, I'm missing the number of electrons. It's 6. Well, it would be 6 for a neutral carbon atom, but we don't always have to have neutral carbon atoms. We can ionize a carbon atom. We can ionize any atom or molecule. And that means we add or subtract electrons to it, or from it, and change the charge on it, change the overall charge. And this is where the problems start, because this is not the number of electrons. This is the number of protons. I'll look in a minute at how we represent the number of electrons. So if you call it the atomic number, it's not attached to any idea in your head. Your brain's looking to find the number of electrons now you've dealt with the number of protons or neutrons. And loads of students will think that's the number of electrons, and it ain't. So let's just call it what it is. Let's call it the proton number. And then we know it's the number of protons. We know to take this away from there to get the number of neutrons. And it's all nice and simple. Of course, what isn't simple is finding the number of electrons now. So let's do that. Right, so how are we going to find out the number of electrons on something like this? Well, let's write our carbon 12-6 again. As we know, that's got 6 protons, because there's the proton number. We take that away from there, away from the nucleon number, to get the number of neutrons. So it's 6, there. Obviously, I'm a diabolist because I'm doing 666. Any religious nutters can phone in and tell me off. Now look, we're carbon-based life forms. Hey, 666. Maybe it all links. Maybe that's where original sin... Oh no, I'm just gone somewhere mental with that. Now look, if we look at the charge here, and obviously the symbol is Q for charge, what we've got is +6 for the number of protons. If it's... Oops, don't put an equals. If it's neutral, then we're adding something to it that means we need naught charge. And what we're adding is obviously -6, and that gives us the number of electrons. It's all fairly straightforward for a neutral atom. Okay, it's a neutral atom, 6 and 6. However, this is where we're going to give ourselves a clue as to the number of electrons, and there's nothing there. And the reason there's nothing there is it's naught. The overall charge is 0, and we're going to write the overall charge on the atom here. And because it's 0, people generally don't write it. It probably would be quite helpful if we always wrote naught. It'd help us think, but we don't. So that's lovely for neutral atoms, but what happens when we've got an atom that's not neutral? And the name for an atom or a molecule that isn't neutral is called an ion. Okay, ion. I'll jot that down in a minute. And the process where you add or remove electrons is called ionization. Now, if we put an extra electron on our atom, so what we're going to do is we're going to add on another electron. Let's see what effect that has on the charge. We've got Q for the charge again. We've got +6 for our number of protons, because you can't adjust that. If you muck around with the number of protons, you change it from being carbon. So that's fixed. What we're now going to do is we're going to add 7 electrons, so we're going to add -7. You should be able to work out that gives me -1 for the charge. So we write -1 up here because that's the charge on the overall atom. Now, we have got a problem, haven't we? Because when we add an electron, we make the atom more negative. So that's counterintuitive. You can see that unless you're careful, that's going to trip you up a bit. You just need to think it through fairly clearly. We're adding negative charge, so it's going to make it more negative. There is a kind of sneaky way of doing this, which is as follows. How can we work out that we've got 7 electrons? We'll change the sign on what's going up here to +1. Don't write it in as +1. It is -1 for the atom, but just change it mentally and then do that to the 6. So 6 + 1 gives me my 7, and that 7 gives me the number of electrons. It's all fairly straightforward. So let's do that now for an atom that is positively ionized. Okay, so this won't change, but now it's +1. Well, if it's +1, I'm even going to go over that in orange. I'm going to take that off. I'm such a control freak. I want to do it in orange so it looks the same as what I did before. Oh man, I need to get out more. So look, the charge now is +6 for my protons again, but now we need to see what would give us +1. Well, obviously if I've got 6 positive charge, I can only take 5 to give me +1. And as you can see, that must mean up here we have +1. Bingo, that all works out. How do we have the number of electrons? We'll change that to -1. 6 minus 1 gives me 5, and that 5 is my number of electrons. So hopefully that all makes sense. This is how you spell an ion. Yeah, that's ion, a charged molecule or atom when you add or subtract electrons to or from it. Ionization is the process. Ionization is the process. Sometimes that's spelled with a Z. I think particularly Americans spell it with a Z. Take your pick. I want to use an S because I'm British. You may have noticed. Now, look. Let's just firm this up with a few quick ones. If I now do this, and I have +2. Some people do 2 plus, as I said, or rather than +2. It's fine. Doesn't matter about the order. If I now have +2, easy way of doing it. Change the sign. Okay, so change that to -2. 6 minus 2 gives me 4. So I've got 4 electrons. And that makes sense. Okay, because if it's overall +2 charge, I've got 6 protons. I can only have 4 electrons to cancel it out. Let's do a few quick ones. I won't bother doing all the Ponzi colours now. So if I do, I don't know, -3, change the sign, 9 electrons. +4. I'm not sure the carbon atom's looking too good now. We've mucked around like that. So we take away, we change that to -4. So we get 6. Whoops, 6 minus 4 gives me 2. So I'd only have 2 electrons. Okay, it's all fairly straightforward. That's some heavy ionization gone on there. So if we pull back and have a look at the whole thing, hopefully this all makes sense. We've got the atom with electrons orbiting the nucleus. They've got negative charge, electrons, protons, blah, blah, blah. We did all that, and then we wrote it for a 666, the devil carbon atom. I don't like atomic mass and mass number or atomic number to describe these. I prefer nucleon number and proton number, so that's what I'm going to be using. You subtract that from there, therefore, just to get this. If we look over here, we then mucked around with the number of electrons, and as we can see, we draw this on the top over there. And the process by which we work that out is fairly straightforward. You've just got to watch out for the counterintuitive. If you add electrons, you make it overall minus, but if you take electrons away, you make it overall plus. That's lovely, isn't it? Now, next session, we're going to talk about isotopes, which are in no way confusing.